Hi, my name is David Klee, and this is Database, Virtual Disks, and You. So a little bit about me. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. I run Heraflux Technologies, a niche consulting company around how databases and infrastructure, and in this case is virtualization, really come together and in some cases don't play nice. We do a lot of performance tuning, and what you're getting is some of the consulting that we normally do, and you're getting it for free. There we go. Okay, first of all, let's start with the four main food groups of IT. So bottom line, there we go. The CPU, there we go. That's not working. There we go. CPU, memory, disk, and hopefully all of you are going to be on flash storage at this point, so may spinning rest in pieces. So all flash, and then networking. So the bottom line, this is really all virtualization is. It's compute resources and queues for how to get there. So what we're going to do right now, we're going to focus just on the disk. Here's the interesting scenario. When you get to all flash, is the storage the primary bottleneck to performance at that point? Maybe, maybe not. It all depends on how you're using it. But what we need to do is we need to go figure this out. Have you ever had a scenario where a DBA comes to you and says, the databases are running slow, it's always storage, and at the end of the day, they're showing you metrics that are just plain off from what you're seeing at the storage? This is real stuff. The problem is, you're both right. There's a lot of stuff in between the storage layer and the database layer, and what we need to do is really map out each one of these layers, because if any one of them are misconfigured or having challenges, it's a bottleneck. And from that point back, it's just going to stack up, and the symptom of this is high latency. So let's take a normal database stack. So database file, no big deal. We've got the database query engine itself. That actually goes and figures out where the thing is at on storage. The storage engine goes and retrieves it. We have to go through the operating system in order to do this. And in the operating system, we've got disk controllers, and in this case, SCSI controllers. Now let's say you followed best practices and you want to use a paravirtual SCSI controller and we keep it off the C drive. There's your standard database practices. This is Microsoft SQL Server for an example. Operating system, data, logs, temp. Pretty standard stuff. So you follow best practices, and those are all daisy-chained off of the PV SCSI controller, and you still get anomalous performance results. The SAN is showing one thing, the database layer is showing 10, 20, 100 times higher. Why? Why are they so different? Well, you throw in a hypervisor in there and it gets even more interesting. So what do? Bottom line, we got to start monitoring this stuff. We got to start monitoring the placement of these things as well, because there's individual queues associated with all of these different options. So if I've got a database, a normal DBA practice is to start spreading out the workload, multiple files. The files are organized into file groups. Maybe I'll have transaction logs in there. This is normal stuff from a database admin perspective in order to gain flexibility, ease of recovery, performance, things like that. Okay, well, at most, you've got 4 paravirtual SCSI controllers that you can use. In this case, I got 5 disks. What's going where and why? Uh-oh, we got transaction logs hanging out. If you start to go scale these things out, where do you put it? And now it all depends on the workload. I can't give you where this thing should go. But now, are things really heavily active on one drive at night and transaction logs are really busy during the day? Or are they really evenly balanced and we just need to pick one and start to gauge and monitor? So it's up to you. Monitor, understand your workload, understand what it's doing as far as just a good operational baseline, and you can start to balance and put competing workloads separated, put similar workloads or stuff that won't conflict with each other, put those together and scale them out that way. So now, what do when we see really interesting symptoms of all of this performance challenges? So let's take that diagram, let's kind of zoom in a little bit now with the hypervisor layer. This is what you have access to right now through ESX Top. So inside the VMware ESXi storage engine, you've got the virtual machine itself. VMware calls it a world. If you look at the disk metrics, you can find the G average or guest average. Our warnings and critical for Microsoft SQL Server and really anything OLTP workloads, 25 milliseconds on read, 10% or 10 milliseconds on write. If you can stay under those, chances are that the database workload is not really significantly storage bottlenecked and that performance is going to continue on as normal. At the virtual disk layer itself, you do have the VMware kernel that this thing has to traverse. If you find kernel time greater than 1 millisecond, something's not right, and you need to go drill into this. And then VMware has the perspective. It can actually see the storage at the other end of the connection. It doesn't know what's in between there, but it can actually manage this, and that's d-average. If you turn around and take a look, this is latency at the device driver itself. With this, if that isn't even close to what the guest average is at, you may have a bottleneck somewhere inside the VMware storage engine itself. A lot of times, though, these particular things will actually be fairly similar. The VMware kernel time will be very low, and then the d-average here will actually line up very similar to what the storage layer at the SAN, from their measurements, their point of view, is actually going to show you. You've also got the ability to track command aborts per second. If that's greater than really 0, well, something's not right. And we may have a faulty path, we may have something really wonky under the hood, and you need to go deal with that. Now, those are the symptoms. Now, what about the root causes of this thing? Guest disk queue length. Inside the ESXi storage stack, you've got the WQ length, or the world queue length. That's basically the virtual machine and all its dependencies. You've got the adapter queue length. You've got the device, basically per data store queue length. All of these different areas you can go track inside ESX top and start to see if you've got bottlenecks inside these different layers. And then you've got any, so HBAs, network adapters, things like that. You can go track that from the switching layer. And then the storage itself, you do also have the storage queue length, which that's basically how VMware sees the storage. But again, you can take this and go to the perspective of the SAN and put the numbers side by side. If they don't line up, something's not right in the middle, and you can see what's in the middle there. It's basically your interconnects. It gets more and more straightforward the deeper you dive into this. If you want the specific metrics to go monitor for this stuff, at the virtual machine layer, it's the operating system disk queue. You've got the virtual adapter QDev. Inside the ESXi layer, storage VM kernel queues, and a big one, DSNRO, or disk sched num rec outstanding. Say that 3 times fast, right? At the HBA, you've got the per path QDev. You've also got the adapter QDev. And inside the fabric and networking, whatever you've got there, link speed, full duplex, half duplex, subnetting, all the overhead that goes involved there with latencies back and forth. And then the storage itself, you have the LUN queue depth on the storage, the latency at the disk pool once it gets out of the controller. You got the array service processors. Are they overloaded? How are those things doing? You got HBA target queues. There's just so many stacks and so many layers in here, but it's not as bad as it seems. There are some pretty common areas that we can actually go tailor and tune. So one, how many of you know about changing the pair virtual controller queue depth? A few. By default, the LSI logic queue depth inside Windows has a queue depth of 32 and you can't change it. It's there for compatibility's sake, not necessarily performance. If you turn around and look at the pair virtual controller, you have a default queue depth of 64, so double the queue depth. But with a registry setting, which is right here, you can actually turn around and override that and bump this all the way up to 254. Do I recommend going all the way up that high? No. Do I recommend changing this until you go test? No. You need to test this and validate that in your environment, your storage layer and your interconnects and everything in between are actually able to accommodate these differences. Most of the time, if you're on flash or flash hybrid storage, I find a pretty good sweet spot at a queue depth of 128 here. But again, test this. Do not just blindly apply these changes because it may backfire on you. There's a KB article that shows you how to do this in both Linux and Windows. And what you're going to find is that in the event that you go change a lot of this stuff, it might not do better because there's one here that not many people know about, DSNRO. So let's say I've got 3 virtual machines. Now, you're following best practices. I got the C drive on the LSI controller, 32 QDEV. I'm using the pair virtual SCSI controller, QDEV of 64. Maybe I've overridden it, maybe I haven't. No big deal. Okay, so I don't want 1,000 data stores out there, so I'm going to turn around and put 3 of these on one data store. No problem, pretty normal, right? Well, disk sched num rec outstanding has a queue depth when multiple worlds share the same data store at 32. So if you've got high queue depth, low queue depth, there's an immediate bottleneck when these things are under pressure, a lot of storage activity, and this is well before it even gets out of the physical machine. So this is why you look at VMware, storage latency is low. You look in guest, say Windows Perfmon, storage latency is high. This is one really strong contributor to this. The good thing is you can go override this. You can override it all the way up to 256. Consult your storage vendor, because what you may find is that they actually may recommend in their best practices guide that you go change this stuff. In fact, there are a number of vendors here I know for a fact that they do. I don't want to name any names. Now, when you do this, you better have a really good baseline of what this stuff is doing, because as soon as you change that, everything around it is going to reflect the change. So the VMware kernel latencies, the ingest latencies, and even the actual load on the SAN, those may go up. The other latencies may go down, because now you're able to have a bigger pipe to get to the storage, and you can do more with it. So baseline before, make the change, test, see how the system responds afterwards. Because if there's a queue further down the stack that may be a bottleneck now, you might actually see it with latencies that rise here as a symptom inside VMware. Keep it in mind, it does add up. This is why it matters. These are real numbers. And I'm not exaggerating when I say I had a customer that was fighting this kind of latency difference. They're fighting it for about 9 months. What we found was that, I mean, it was fascinating. The database layer was seeing over 50,000 long I/O alerts every night. And inside SQL Server, a long I/O alert is an I/O command that takes over 15 seconds to complete. 50,000 of these a night. The storage admin, everything's fine, go away. And the numbers that they were looking at were honestly really good. And I get brought in by the database team to basically be a punching bag, I mean intermediary for this stuff. And what we found was that both were right. But in the very first meeting, they had been arguing this for so long, the storage person was so mad that they brought in somebody else to spot check his work, picked up a chair and threw it at the DBA. And if you've ever picked up one of those Herman Miller Aerons, they're actually pretty heavy. This guy was pretty good. What we found, DSNRO, HBA queue depth, switch queue depth. We went and cleaned them up, and the ingest latency dropped to match exactly what the storage latency showed. Here's the problem. They were both right. It all depended on the point of view. Storage consumption can bury you. And if you have ingest bottlenecks, it can trickle downhill and it can cause you a really bad day. I mean, not only that, but I mean, I'm not going to say the DBAs are, golden with this stuff. I mean, database administrators, developers, they can miss a lot of this stuff. I mean, for example, right here, this was essentially bad code. In this case, yeah, it was. So we're just going to blame the developer because we all kind of like doing that, right? So blame them when you have evidence. In this case, it was kind of interesting. The DBA missed the fact that the developer scheduled a job to run every second instead of every hour. In this case, the storage array was good enough to where it actually insulated it and nobody noticed. But if you see how it drops off at the end there, I wanted to say, it was actually in a training class. We were looking at all the measurements, and I go, what the heck is this? You got a spike a month and a half ago, and you're eating 600 to 800 megabytes a second for the entire last month and a half. And they go, ooh. So we get in and looked at it, and sure enough, we found it. Simple misconfiguration, simple oversight, and you can see at the very bottom, yep, we fixed it. It's what happens when this stuff matters. It's just interesting. So if you change the queue depths, if you watch and profile this stuff, all these things can change. Bad code, I mean, it's all the way from the top, big problems. If you clean this stuff up, you clean up the underlying storage, you're able to use your storage much more effectively, and at the end of the day, you're getting what you paid for at the storage, the end user performance is better, the database layer performance is better, everybody's happy. So monitor your workload, go through these layers with a fine-tooth comb. You don't have to do it every day, but go through and look at this stuff because it really does matter. And these default options are just not good enough for demanding database workloads. If you have any questions at all about this in the future or down the road, feel free to contact me here. I'm an absolute geek. I love working on this stuff. Every environment's different. It's always a challenge, and I find it a lot of fun. Maybe I'm weird. If you have any questions, let me know. Any questions in the audience? Yes, sir.
Queue depth setting, on one of the slides you had a queue depth setting. Where was that change at? Where did you set that at? Is it
DSNRO? Yeah. The question is, where do you actually go change a DSNRO setting? It's actually inside VMware configured per LUN. Yeah. Yes, sir. If you have dedicated LUNs and dedicated data stores, it'll actually retain the queue depth of whatever's coming into it. So in that case, you're okay. Do I recommend that? It's probably overkill and it's a lot to manage. Do you need it? I mean, if you've got that kind of database workload, yeah. If it's a really high workload, would I recommend it? Most likely. Just because of this kind of stuff, you don't really have to worry about it. For normal workloads, change a DSNRO, watch it, validate it, probably perfectly fine. Cool. We'll give it a wrap. If you have any more questions, I'll be right out here. Thanks for coming, everybody. This was a lot of fun.